Hello, and welcome to a new Liftinstituut expert session. In this series of short video discussions, experts from all around the world share their knowledge, experience, and views on different vertical transportation subjects. Today is the first part of a new series where we discuss safety components, how to develop them, how to get them certified. And joining us are three product specialists from Liftinstituut: Tolga, Goktas, Mohamed Issa, and Wouter Bijlsma. Gentlemen, welcome. Thank you for coming.
Thank you.
Let's go around. I want you to introduce yourself and say a bit about your experience and what you do. Tolga?
Yes, hello Kevin. My name is Tolga Goktas, and I have been working at Liftinstituut for almost 2 years right now. And before joining Liftinstituut, I had worked for the lifting industry for 6 years with many different responsibilities.
Sure.
Like project engineer, test engineer on the site, and I'm mechatronics engineer, so yeah, I can say.
Right, yeah, fantastic. Mohamed?
Yes, well, product specialist also at the Liftinstituut. I have experience before in the heavy machineries back in the Middle East.
Okay.
And I joined Liftinstituut recently, so to be part in the mechanical components, certification of mechanical components, let's say.
Wouter?
Yeah, I started Liftinstituut at the beginning of this year, and before that I was electrical engineer, 13 years at a big manufacturer of elevators. And I'm mainly focusing on electronics and in the certification area.
On electronics, yeah.
Yeah.
Interesting.
So,
yeah, and we'll get to that and what the difference is, but let's start with a big question, like what is a safety component? What counts as that? I might define that as every part of the elevator, but I understand there's a definition, yeah?
Yeah. So, for instance, in our daily life, we experience lots of activities, and like driving your car, you are feeling safe because there are safety components there. Normally they are not used when you are driving, but when you are in an emergency situation or an accident, they become active, like an airbag.
Right.
So an airbag you can count as a safety component.
Okay.
Also in the lift industry you have safety components that protect you from hurting yourself or even worse.
Right.
And they only become active when something happens that is not normal.
That you don't want to happen, Can you give us examples or what types of safety components?
Yes, in Annex 3 of the Lifts Directive, the safety components are defined under 6 clauses.
Okay.
I can start with the locking devices for landing doors.
Okay.
The elevator doors are designed not to be opened by the end users, because it can cause very dangerous situation and maybe big accident.
Yes.
It is same principle with your cars. For example, you cannot open your door from inside.
Sure.
While you are driving, or you don't want somebody else to open your doors while you are waiting in front of the traffic lights.
Absolutely, yeah.
Yeah, and the second safety components, which is described in the Lifts Directive, is about devices to prevent car from falling or uncontrolled movements.
Okay, got it.
So if I need to give an example from elevator system, I would say safety gears and UCMP system, which is the abbreviation of unintended car movement protection.
Unintended car movement protection.
Correct.
Got it. Just stop you from falling is how, understand.
And third of them is about overspeed limitation devices.
Okay.
Every elevator is designed with a maximum velocity, and in every elevator system, there is a detection system for overspeed.
Okay.
So this system is checking whether the elevator exceeding the maximum velocity or not.
Okay.
So if the elevator exceeds that maximum speed, the overspeed limitation devices or system will trigger the stopping elements.
Got it.
So overspeed governors can be given as an example under this clause.
Okay, got it. Mohamed?
Yes, we have also buffers, which is kind of considered a safety component. They act like a shock absorbing in case of impact. Additional to this list, we have an electrical safety devices, which is in the form of safety circuits containing electronics.
Okay.
So you can imagine it of an electronic component, a safety circuit, a logic behind it, which is a part in the safety feature or taking a safety decision.
Yeah. Okay.
To add to all of this, we have, in case of hydraulic lifts, we have a few components which are exclusively used in hydraulic lifts, such as restrictors and rupture valve.
Okay.
They go hand in hand in case of you have a leakage or you have uncontrolled burst in a pipe or something like that.
The fluid that keeps the whole system upright, protects against that.
Exactly.
Makes sense. Okay, got it. So if, God forbid, an elevator finds itself in free fall, then these are the systems that kind of come into play, like an airbag, as Wouter said. So not necessarily preventing against it, but reacting to it. Is that correct?
Yeah, you can say that. Yeah.
And innovation happens all the time with every field. And let's say a manufacturer or an inventor comes up with a new safety component, an idea to make elevators safer. They can apply to have that certified. And what is the process involved in taking a safety component and having it certified? Wouter?
Yes, well, you have the LIFT directive, which describes those safety components.
Yeah.
And there are procedures for it.
Okay.
So it is described in that directive how to certify those products also.
Got it. Yeah.
The EN 8150, which is the standard, tells us how to test those kind of devices.
Okay.
And so we at Liftinstituut first try to get all the information from the manufacturers, like manuals, technical descriptions and everything to understand what the component is and what its actual safety function is.
Right, yeah.
So that's very important to know.
Right.
And then we have a look at all the technical drawings, the calculations, if they are correct,
Right.
If it all fits and matches the safety level it needs to be.
Yeah.
And then after that, the components actually have to be tested, of course, to match the calculations, but also match the specifications.
Yeah.
So we also look at that to see if the tests are being performed correctly and also in a good manner. And if we can say that everything went well, everything is safe enough to meet the requirements of the directive, then we can certify it.
You've mentioned the standards and the norms that elevator manufacturers need to follow to keep everyone safe. Does that always correlate with what's available on the market, or are there products available that the standard does not yet address?
Yes. Well, in most cases, the standard covers most of the product available on the market. However, it's not always.
Okay.
New ideas and technologies always tends to find its own way to the elevator world.
Right.
And with that said, we always have some kind of a component that we don't have a requirement for it in the standard.
Yeah.
But in this case, the component still can be certified. It doesn't mean that it cannot be certified. However, we call it as deviation or
Deviation, okay.
it's like deviating from the standards. And for this, we have a different process for it, which required a risk analysis and a risk assessment.
Right.
To ensure that the product is still having an equivalent safety level as compared to the traditional component listed in the standard.
Yeah, and I was going to ask about technology and how it affects it, because there's, with the progress of technology, tomorrow somebody might invent a floating elevator that uses some new technology, and that has to be a challenge that you deal with, yes? New inventions that aren't in the book as it's written now, yeah?
Yes, correct. Yeah, as you may agree with me, the new technology and its components cannot be predicted in advance.
Yeah.
So when the manufacturer wants to apply these new techniques, new technology, and their components, probably it will deviate from the standard.
Yeah.
Yeah, you can think about overspeed governors.
Sure.
Now, in a conventional system, they are mechanical. But nowadays, it can be done with software and logic.
Wow.
It can be detected by software and logic. Yeah. So after detection, okay, something needs to be triggered the safety gear to stop the elevator. So these parts can be done with some kind of electronics,
Right.
like coils or solenoids.
Yeah.
Yeah, and also there are many benefits of using this new technology to the safety components, because the first advantage is, I can say that it gives you a big space advantage, because the mechanical components are bigger than the electronic parts.
Sure.
So when you use electronic components instead of mechanical ones, you will gain a lot of space.
Yeah, absolutely.
So secondly, I can say they are cheaper and I guess easy to produce and easy to maintain these products. And let's assume they are broken and they need to be replaced with the new one. So you don't need to spend a lot of time to change with the new one. You can change it with the new one in no time.
Yeah. So it has to be a complicated process. You can certify a mechanical component, that it works to a certain amount of strength, for example. But certifying an electrical component or software has to be an entirely different challenge. Is that right?
Yeah, that's an entirely different challenge. Mechanical is, of course, you can see it, you can hear it, you can.
Exactly.
But with software and electronics, it's just one magic black box. So we have the EN 61508 standard for manufacturing and developing actually safe programmable electronics. So we use that standard as the base of our certification process.
Okay.
And also the standard describes how to test also.
I was going to say, you must stress test the software in some way.
Yeah, with software you have to insert kind of errors. So when something a bit falls down, for instance,
right? Yeah.
You have to know how the software reacts, and if you still have a safe situation at all with any problem, actually.
Right.
So also when the memory goes completely full, you have to know if you still have a safe situation after that.
Exactly, yeah. Account for all of the possibilities. It's a relief to know that the certification exists, that the standard exists for the software, just like it does for physical objects. Yeah. Tolga, the example of an elevator free falling, and it's my favorite thing to talk about when I talk about elevator in general, but the safety mechanisms are there. And specifically what happens, in an emergency situation, how do these safety components come into play?
Yes, before answering this question, I need to say that this is not a very common thing in practice.
Just for the record.
In case of free fall, there are two components which works together to stop elevator.
Okay.
What are they? Safety gear and overspeed governor.
Right.
Yes, overspeed governor is there for detecting whether the elevator exceeding the maximum velocity or not.
Yes.
When the elevator exceeds that specific velocity, we call it overspeed. The overspeed governor will stop itself immediately.
Okay.
So there is a one rope between safety gear and overspeed governor, which provides a connection between them. And while elevator is moving and overspeed governor stops.
Okay.
This rope will be pulled by the overspeed governor and activates the safety gear.
Nice. So physically interlinked.
Safety gear includes wedges in it, and these wedges are ready to grip the rail to stop the elevator.
Fantastic.
And this is how the elevator is acting in case of free fall.
Okay, got it. That's fantastic that exists as well. And we mentioned new products before, new innovations that can exist. What is the exact process for getting Liftinstituut involved in certifying these?
Yes, well, for products within new innovations, innovation is always presented as challenges. It comes with the new ideas. You have to think of the recent 40 years, a lot of developments come into general technology where we see it in our practical life. And this have an impact, of course, on the safety component. So with the new ideas and new technologies, and new risks comes. So it's our job to analyze this risk and to see which type of impact it can operate on that level. and it should be analyzed on all aspects just to ensure that the product with the new innovation still meeting the safety requirement of the lift directive.
Sure.
This is also comes along with comprehensive testing and examination, just to get a full confidence in the product before putting it in the market.
Amazing. Great that you are doing this invisible, very important job that I know very little about, and even to the extent of software, being able to stress test that and ensure that even the elevators of the future will still be able to keep everyone safe inside. Well, Mohamed and Wouter and Tolga, thank you all for coming, and thank you for joining us today for another Liftinstituut expert session. You can find more expert sessions on the Liftinstituut channel, so click subscribe to follow us on YouTube. And did you know that the Liftinstituut expert sessions are a podcast? You can go to your favorite podcast app and search for Liftinstituut to follow us in that way. Comment below if there are topics that you would like to see discussed in a future expert session, and we'll see you next time.